Hey everybody, welcome back to another MR Academy Math video. And today we're going to be taking a break from the data and statistics videos that we have been working on, talking about graphs, talking about tables, all that kind of stuff. And in this video, we're going to be discussing two things that have to do with numbers. We're just jumping back into numbers and trying to kind of figure out patterns of numbers and looking at those specific patterns, okay, what numbers make up other numbers, and what numbers you get when you multiply other numbers together, okay, just a bunch of weird kind of things like that. And we're going to be talking about that in the next couple of videos. Okay, we're going to be talking a lot about how numbers are made up. And in this video specifically, we're talking about two things, factors and multiples. Okay. Now, you may have heard those words before. You may have heard the word factor in other uses, maybe not a number use of the word factor. But a factor, put simply, is numbers that you can multiply together to get a bigger number. And a number can have two or more factors. Okay. Prime number, we're going to get to that in just a moment. I'm going to skip over that. But just to kind of help you understand what a factor is. Okay, so let's take a bigger number. Okay, let's take a number like 24. Kind of hard to see, but yes, that is a 24. For some reason, the ink didn't print very nicely on this one for me. But we're looking at the factors of 24. We want to know what numbers we can multiply together to get 24. And those numbers that we can multiply together are 1 and 24. 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. And the same way, we can go backwards. Okay, we can say 6 times 4 is 24. 8 times 3 is 24. 12 times 2, 21 times 1. All of those equal 24. So each one of these things is a factor of 24. They are a number that you can multiply by another whole number to get the big number, okay, to get 24. Those are all factors of 24. 1, 2, 3, 4, 6, 8, 12, and 24. Okay, so those are factors. A prime number. Prime number is a special number that only has two factors, only two. So take 13, for example. It only has two factors, two things that you can multiply together, two whole numbers you can multiply together to get 13. 1 and 13. 1 times 13, that is it. Okay, those are the only two whole numbers you can get that you can multiply together to get 13. Very, very different from 24. Okay, so those are factors, numbers that you can multiply together to get a certain bigger number. Okay, so that is one of the patterns. Factors multiply together to get up to a certain number. Okay, so the factors are smaller than the number. Okay, so in this case, 24 was our number. The other one that we're looking at is this one in blue right here, a multiple. Okay, and a multiple is a product, which means multiplied. Okay, we're multiplying a number by something else. A multiple is a product of a number and another whole number. Okay, so for example, here we have 12. Okay, 12 is our number that we're going to be multiplying by something else. And we're doing that for each one of these. And a multiple is going to be bigger than or equal to whatever that number is that we're starting with. Okay, so for our example here, we're using 12. Up here we use 24. Down here we're going to use 12. So 12 times 1 is 12. Okay, so 12 is a multiple of 12. Okay, we can multiply 12 by a whole number, 1, and get a number that's equal to or bigger than the number we started with, 12. We can multiply 12 times 2. That gets us 24. 24 is a multiple of 12 because we can multiply 12 by a whole number, 2, to get to 24. 36 is a multiple of 12 because 12 times 3, another whole number, is 36. 48 is a multiple of 12. 12 times 4 is 48. So that would make 48 a multiple. You could say 12 times 100. Okay, that would be 1,200 is a multiple of 12. 12 times a million. Okay, 12 million is a multiple of 12. Okay, so there are an endless number of those that you could find. Where factors, there's only a certain number of them for each number. Multiples, you can keep on multiplying and multiplying and multiplying and multiplying forever. And you're going to keep on finding more and more and more multiples of a certain number. Okay. So factors are the smaller little bits and pieces that you multiply together to get a bigger number. A multiple is a number that you multiply some other number by to get. Okay. And then a prime number is one of those special cases where, and we'll talk about this in the next video that we can get into, prime number only has two factors. Okay. One and itself, whatever it happens to be. Okay, if it's 17, the factors are only 1 and 17. You can't multiply any other numbers, whole numbers together to get 17. Only 1 and 17. 7's another one. 1 times 7. Okay, nothing else can you multiply together to get 7. Okay, so let's take a look at some practice problems here. 1, 2, and 3. We want to find the factors for each one of these three numbers. Okay. So number 1, 5. We want to think, okay, factors need to be less than or equal to whatever number we're working with. So we know our numbers that we're working with have to be 5 or less. So which numbers, 5 or less, whole numbers, multiply together to get 5? Well, there's only two that come to mind, 1 and 5. We can't multiply 2 by anything, by any other whole number to get 5. We can't multiply 3 by a whole number to get to 5. We can't multiply 4 by a whole number to get to 5. So the only factors for number 5, or for number 1, 4, 5, are 1 and 5. That's it. That's all we have. Number 2, 8 is our number. So once again, we have to think, okay, it's got to be 8 or less. The only numbers we can work with are 8 or less, whole numbers that are 8 or less. So can we multiply 1 by a number to get to 8? Yes, we can. 1 times 8 is 8. So we can say, okay, 1 is one of the factors. Can we multiply 2 times something to get to 8? We certainly can. 2 times 4. 3, can't multiply 3 by a whole number to get to 8. But we can multiply it by 4. 2 times 4. And nothing for 5, not 6, not 7. But 1 times 8, we decided before, is a way to get to 8. Now you notice, just like we had up here, there's a pattern to this. Okay, when we were looking at 24 before, we decided that in order, 1, 2, 3, 4, 6, 8, 12, and 24, if you put those numbers in order, you notice that the first and last number multiplied together give us our number. Our next biggest factor and our next smallest factor, 2 and 12, they multiply together to get 24. The next one and the next one, 3 times 8, that's 24. 4 and 6, that's 24. Take a look at number 8 down here. 1 times 8 is 8. 2 times 4 is 8. 4 times 2 is 8. 8 times 1 is 8. There's a pattern there. Okay, there's a reason for that. That's how that works. Okay. And number 3, well, we talked about 13 up there. The only factors we have for 13 are 1 and 13. That's one of those special prime numbers, kind of like 5. 5 is a prime number as well. Only 1 and itself. So those are some factor examples. Let's do some multiple examples. Now this one helps to know your facts. Okay, when it comes to multiples and factors both, it helps to know your basic multiplication facts. It's going to make life a lot easier for you. Some of the bigger numbers, if you do start to multiply, like 24 times 8, that's not usually as easy to do in your head as 2 times 4. So if you do need a calculator for something like that, feel free to use it. But numbers like this, if we know our basic multiplication facts, we're going to be in good shape for 2, 4, and 6. So number 4, we have 2. 5 multiples for each number. Well, let's just do the next 5. Okay, it's going to make our life a little bit easier here. 2 times 2 is 4. How about 2 times 3? 6. 2 times 4? 8. 2 times 5? 10. 2 times 6? 12. Those are the next 5 multiples. Good stuff. And you notice we have a pattern there. 2, 4, 6, 8, 10, 12. How about number 5? We look at number 4. Okay, the number 4. Well, 4 times 1 is 4. Let's try 4 times 2. That's 8. 4 times 3, 12. 4 times 4, 16. 4 times 5, 20. 4 times 6, 24. There we go. There's 5 more multiples of 4. We had 4 times 1 over here, but then 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6. All multiples. Okay, we're taking our starting number, and we're finding numbers that are larger than that. Okay, numbers that we can multiply, whole numbers we can multiply our starting number by to get a bigger number. Number 6, our number is 6. 6 times 1 is 6. Well, let's find the next 5. 6 times 2, 12. 6 times 3, 18. 6 times 4, 24. 6 times 5 is 30. And 6 times 6 is 36. Those are the next 5 multiples of 6. Okay. So, factors, multiples. Let's take a look at a few more examples. Let's check out the factors that we have at the top of this page. That's going to be our focus again. So factors, we're talking less than or equal to whatever number we're looking at for factors. Okay, numbers we can multiply together to get our starting number. 3, well, 1 times 3 is 3. And we can't multiply anything whole by 2 to get to 3, so it sounds like we have a prime number here. Just 1 and 3. That's all we have. Same with 5. We discussed 5 before. 1 and 5. That is it for that one. 12. Well, we can multiply 1 times 12 to get 12. 2 times 6. 3 times 4. 4 times 3. 6 times 2. And 12 times 1. And those are our 6 factors right there. 1 times 12, 2 times 6, 3 times 4, 4 times 3, 6 times 2, and 12 times 1. Those are our 6 factors. 18. We got a very long line there. Don't know if that means anything, but we're going to find out. 18, well, 1 times 18 is 18. 2 times something is 18. What is it? 2 times 9. So we can say 2. 3 times 6 is 18. 4 times 4 is 16. 4 times 5 is 20, so 4 doesn't work. 5 doesn't work because 18 doesn't end in a 0 or 5. But 6 does work. 3 times 6. All right, so now you notice we're starting to go back and forth. So we had 3, now we have 6. Well, 3 times 6, 6 times 3. 2 times what did we decide was 18? 2 times 9. And then 1 times 18 is our final factor. So 6 for number 12, and 6 for the number 18 as well. Now number 5, well, 1. All numbers at least have 1. 2, well, it ends in 2, so we can definitely say 2 is one of them. 4 is not going to work. 3 is not going to work. In fact, I don't think anything is going to work until we get to 11. 2 times 11 is 22, and 11 times 2 is 22. And then, of course, 1 times 22. Just 4 factors for that one. Number 6, we have 34. Okay, so once again, 1. Every number has 1 as a factor. 2 does end in a 4, so we can divide it by 2. 2 times something is 34. But 2 times what? Well, I'm thinking off the top of my head, I know 3 is not going to work, 4 is not going to work, 5 is not going to work, 6 won't work, 7, 8, 9, 10, 11. I think we're going to get all the way up to 17 before we find something that's going to work. 2 times 17 is 34, and then 34 is the only other one that we have. So some of these bigger numbers, like 34, and even bigger numbers than that, sometimes they're only going to have maybe 4 factors, maybe only the 2 if they're prime numbers. Okay? So just because we have a bigger number like 34 and there's only 4 factors doesn't mean we did anything wrong. Some numbers just work out that way. That's just kind of how it goes. All right, number 7, find the first 5 multiples for each number. Well, again, we're going to assume that they gave us the first multiple here. We're just going to say, okay, 4 times 1, 5 times 1, 8 times 1, 11 times 1. Okay, I want to find the next 5. So 4 times 1 is 4, 4 times 2, 8, 4 times 3, 12, 4 times 4, 16, 4 times 5, 20, 4 times 6, 24. 5, well, we have 5 times 1 is 5. I want to find the next 5. So 5 times 2, 10. Times 3 is 15. Oh, boy. Times 4 is 20. That is a 20. 25. 30. 8. 8 times 1 is 8. 8 times 2, 16. 8 times 3, 24. 8 times 4, 32. 8 times 5 is 40. And 8 times 6 is 48. And then we have 11. 11 times 1 is 11. 11 times 2, 22. 33, 44, 55, and 66 is what we're looking for there. And then down here, we have a word problem. If you eat 10 grapes each day, how many grapes will you eat in 9 days? In 10, 11, 12 days? Okay, so we're looking for those 4 numbers. If you eat 10 grapes each day, how many will you eat in 9 days? Well, 10 grapes, 9 days. This sounds like a multiplication problem, and it looks like we're looking for multiples. So 10 times 9 is 90. 10 times 10 days gives me 100. 10 times 11 days is 110, and 10 times 12 days is 120. Okay, so we're looking for 10 grapes each of the 9 days, 10 times, or 10 plus 10 plus 10 plus 10 plus 10 plus 10, all the way up to 9 days. Okay, and then 10, 11, 12, that gets me the 90, 100, 110, 120. Okay, so factors and multiples. Hopefully that makes more sense. Okay, they can be a little confusing to start with, and later on we will do more stuff with this. We'll do things called factor trees. We'll try to do some greatest common factors, least common multiples. We're going to get pretty fancy with some of the stuff we're going to do. But this is where we're going to leave this one for today. Just letting you know what factors and multiples are. Just a very basic understanding of what they are and how to use them. So hopefully you did find this useful. If you did enjoy this video, if you learned something new, if you found this helpful, do hit that like button, drop a comment, let me know that it helped you out. Let me know that you found it useful and interesting. And if you want to be notified of any future videos that I upload, hit that subscribe button, ring that bell, and you will be notified whenever I upload any new content. Greatly appreciate it if you would do that. But otherwise, stay tuned for the next video. I do believe I'm going to talk about prime and composite numbers in the next one. So we'll come back to that prime number idea, just having one and itself as factors. And we'll also talk about what a composite number is, which is kind of the opposite of what a prime number is. Pretty easy stuff. We'll talk about that in the next video. But thank you for watching. I hope you have a great rest of your morning, afternoon, evening, whenever you happen to be watching this. And until next time, I hope you all take care.